Welcome to day 2 of Build Stuff. I'm here with Diana, AWS Solutions Architect. She's here to convince me that AWS CDK is the best thing in the world. As a fan of infrastructure as code, I can't wait to hear your presentation. So with that, I'll hand it over, Diana.
Yeah, hi Bill, hi everyone. Delighted to be here. I'll start by sharing my screen and kicking this off. So start looking good. Presentation visible? Excellent. So yeah, hi everyone, good morning. My name is Diana Cheng and I'm a senior solutions architect at AWS for the last 1.5 years. And I worked before AWS on Java application development and architecture as a consultant and team lead, and really happy to be here to be able to deliver this short talk to you. And so thank you to everyone at Build 2021 for Build Stuff 2021 for this opportunity. And yeah, just to let you know what we're going to cover today in this session, I'd like to provide you an overview of CDK. What is the problem that it tries to address? What are the advantages of using it? So it's an introductory level session with examples in Java. So aim for those that are still new to CDK. So if you're already familiar with it, it can mostly serve as a refresher, but there wouldn't be all that much new for you. This session assumes working knowledge of AWS, so that you are somewhat familiar with its services, that you've used some of it before, but of course, not on an expert level. So we'll talk about how to manage our infrastructure as code and build reusable components in CDK. And also we'll touch on how to integrate this into deployment pipelines and how CDK promotes a GitOps model. I'll also talk a little bit about what is some sort of open ecosystem that has emerged around AWS CDK and other projects within that ecosystem. And we'll have a few minutes for questions at the end. So let's get started. If we think about how we manage our infrastructure in the cloud, in this case in AWS, there are different ways to do this. And typically we would start working with a more or less manual approach. So UI-based, we could go to the AWS console and provision our infrastructure by kicking around in the web interface, which is, a pretty straightforward experience. It's easy to get started with it. But at one point, we start seeing that we need more and more environments, and then there are multiple people involved in that process as our systems start to grow in the cloud. And for that reason, we start kind of regretting that it's not reproducible, that we need to do it again, and that it's time consuming and are prone to do it all over again via the UI. So we look for a different and better approach. And we think, well, probably we can script this, right? So we can take the AWS SDK, which is making API calls behind the scenes for you. And we start automating this through code. And we define an imperative approach, right? We tell our script via code what it needs to do to provision that infrastructure in the cloud. And this is a lot better. Now it's more or less automated. We start coming towards a problem though, again, when we think about, how do I change things? Okay, I don't want to provision new infrastructure now. I actually want to make updates. And what happens if I want to roll back? If things go wrong, if an API call fails, how do I roll back to the previous version? And even if things don't necessarily go wrong, how do I know that my infrastructure has finished provision in the cloud and I'm ready to use it? We don't really have any indication of the lifecycle states of that infrastructure. So this was good, but we look for a better way and we come across provisioning engines. Provisioning engines are powerful tools that helps us work in a bit of a different approach. So instead of an imperative approach, we work declaratively now, which means that we specify instead of the instructions of how to provision infrastructure, we tell the provisioning engine what is the state of that infrastructure that we want, what is the desired state of that configuration. And things become, with that, easier to automate, and now we have really a more reproducible way of provisioning our infrastructure. And best of all, it actually deals with these challenges of change management, right? So it will do that heavy lifting of knowing what needs to be updated to go from the existing state towards the new state. It will take that job of calculating what are those steps and really reaching that new desired state that we have specified that we want for our infrastructure. So these provisioning engines are powerful, and they let us specify this desired state in the shape of configuration files, right? In CloudFormation, we have this CloudFormation templates that come in the, you can develop in JSON or YAML format. And for Terraform, you have the HashiCorp configuration language as the templating format that you would use. And then you give these configuration files to the provisioning engines, and they'll take that, they'll do that heavy lifting of figuring out what needs to be done in order to provision our infrastructure or update our infrastructure and have it in the state that we have specified in those configuration files. And that's already pretty cool, and it's powerful. But later we start, the more and more that we work with these configuration files, we start realizing that they can become really long. They can be verbose in their syntax, so we end up with really large files. And also that they don't really provide us any abstraction. So we don't really have any reusable modules most of the time. We can't really take an abstraction and instantiate it again and use it somewhere else. So that is not very convenient. And also these templates really force us to provide a lot of detail, like every single detail about that infrastructure that we want to provision. So it really can be a little bit cumbersome depending on what you're developing. As we put more and more services together, our templating files start to grow. Let's just take this quick example of a static website hosted on an S3 bucket and fronted with a CloudFormation distribution. It typically runs two resources in our heads, right? The S3 bucket that hosts our static website, and then the CloudFormation distribution. But this configuration file, this template, actually has 92 lines of code or 92 lines of YAML, right? So though it's quite a lot, and it will become bigger the more we compose services and the more we start building larger and complex systems. So this is where the motivation for AWS CDKs come from. It's about managing a little bit better the complexity of infrastructure, so moving away from having to manage those templates, and also having a way of creating abstractions, of having those abstractions and being able to reuse them, of implementing patterns when we know that we have common setups, right? Like common cases of repeated services that need to work together. How can we model that and reuse them? And how do we stop using this configuration files, right? That is not really code and that doesn't provide us those abstractions. We would like to start using programming languages. That would be the best. So this is really what AWS Cloud Development Kit does. It's really a software development framework for defining infrastructure and cloud resources as code and in the form of reusable components. So we will declare classes that have methods, and this will be our abstractions that we can instantiate again in the same application or in different applications and reuse that. And because we're working with code, we will get a lot more tooling available to us. So we can use IDEs, which will provide us autocomplete, and also inline documentation. So we get the documentation as we start coding, and we have it there. And as I mentioned, those abstractions will be, or we will have abstractions to work with, and we can implement our own abstractions that will be in the form of reusable classes, but they will also provide us with a lot of what we know as same defaults. We don't need to specify with AWS CDK necessarily all the properties for our infrastructure. There will be defaults as assumed for us if we don't provide those extra properties. And that is very useful because we can simply declare things with more brevity. Defaults will be assumed, and we can move on and start coding a little bit faster. So if we look at the concepts of AWS CDK, we start with, we've talked about this being code, and this code will start with an AWS CDK application. Within this application, we will have one or more stacks. And the stacks are the unit of deployability. The stacks are what we're going to deploy on AWS or in the cloud. And there could be one or more stacks within a CDK application, really up to dozens working across maybe multiple regions. You can have one stack for production and one for pre-production. It's up to us. And within those stacks, we're going to define what we know as constructs. We're going to define actually a tree of constructs. Excuse me. And we're going to see in a minute what I mean with a tree of constructs. And a construct is really the key abstraction. It's the key concept in the CDK programming model. The construct is where we're going to define the configuration of our cloud resources, where we're going to instantiate our cloud resources. It could be a bucket, an S3 bucket, for example, or it could be an SQS queue that is where a Lambda function is listening to in order to get triggered when new messages start arriving into this queue. And once we have this application that has one or more stacks and has some constructs with our specification of the services that we want in the cloud, we're going to take that code and we are going to actually convert it. So we say synthesize it into a CloudFormation template. So actually, CDK is not reinventing the wheel. Underneath is using CloudFormation. And we're going to convert this code. So we could write our infrastructure and our desired state for our infrastructure as code, but we're going to convert it into a CloudFormation template. And then we're going to give the provisioning engine, which is CloudFormation, the CloudFormation service, that template so that it provisions our resources in the cloud. And that's actually quite good because we have seen that CloudFormation as a provisioning engine does a lot of things for us already, like managing rollbacks, managing updates, detecting drift in case changes have been done manually. And that's really good. CloudFormation is proven. There's a lot of know-how around it. And if you're unsure about your CDK application, if things should go wrong, you can always check the CloudFormation template that gets synthesized from your code and check that out and see what might be wrong. So that's pretty cool. And at this point, AWS CDK is available in several languages. So we have support for TypeScript, JavaScript, C#, Java, Python, and a developer preview of Go. So you can pick the language of your choice. When we start creating our constructs, which are basically nothing but classes that represent our infrastructure, our constructor, so we'll use a construct that is already available in CDK, or we'll develop our own, and we'll see that the constructor of our construct will take several parameters, and the first one is going to be a scope. So where am I allocating this construct? Where does it live? In the case of this construct here, they live in the context of a stack, and the stack lives within the scope of an application. We'll also see that we require an ID, and we'll see that we also will need some optional properties. I mentioned that if I don't provide the properties, then some defaults will be assumed, but of course we can provide those properties. We can specify how we want our infrastructure in great detail to be provisioned. And I mentioned also a tree of constructs. And this means that really that we start with our application, as we see here, and we start placing some stacks within our application. We include some stacks in our application, and we start including also some construct within those stacks, right, as we see here. And within those constructs, I can also instantiate other constructs. I can take a construct that I've seen available in GitHub and that I want to consume, and I'll instantiate it within a construct to be reused, right? And this creates a tree. We always provide the scope, as I mentioned. So this construct will have this construct as its scope, kind of as its parent, as we want, or like the place where it lives. And this one will have the stack as its scope. And we end up with a tree. And this is important because constructs need to have an ID. And an ID needs to be unique, but it needs to be unique only within the scope of a construct. So if I'm taking a construct and reusing it, from the internet, everything which is living within this construct, and that construct itself will have an ID, which is not going to clash with the IDs that are in construct that have a higher scope. And that's pretty useful for us if we want to reuse stuff. If we bring a construct in, we don't have to worry about the IDs that are, specified within that construct. We can simply reuse it, and there is no probability that it's going to clash with the IDs that I'm defining in higher scopes of my application. Now let's take a look at what are the main components of CDK. So what do we need when we actually start developing our CDK applications? We of course need to include the core framework, CDK itself, the core module in Maven, for example, because we're going to talk about Java implementations today. And this is what will let us, instantiate a CDK application and some stacks and start instantiating constructs or creating our classes that extend from a construct. And once we define our application, we'll have to convert it to CloudFormation. So for that, we're going to need the CDK CLI. And this is a command line tool, just like the AWS CLI, which will come with some useful commands for us that, for example, allows us to initialize our CDK application. We'll see in a minute what that means. Synthesize it or convert our code into a CloudFormation template, and deploy it, actually give it to the provisioning engine and have it deployed in our AWS account. And we'll also, most of the time, need to use the AWS construct library. So those services, we will want to use services in the cloud, and CDK already comes with this construct library, which is constructs for each service. It means it's providing us constructs for each service in the AWS cloud. So there will be a construct for Lambda, there will be a construct for DynamoDB, and we can just start using this. This is an AWS curated list or libraries of constructs, so that we can, as I said, easier start working with the services and specifying them with less code and less mandatory properties than we would need to do with CloudFormation templates. Constructs have different levels of sophistication, different levels of how much they're going to do for us under the hood. And the easiest and simplest type of construct is the level 1 construct, which is really a one-to-one representation with a CloudFormation resource. So if we define a level 1 construct in our CDK application, in our code, this will transform to one resource in CloudFormation. So it's not very different than working with CloudFormation resources. And this is the simplest level of construct that we have. We also have the level 2 constructs, which relate to specific services in AWS. So we'll have a construct for the VPC or for EC2. And these constructs will do a lot more for us under the hood. They're going to wire up several things. And these are the constructs that if we don't provide or specify all the properties, will assume several same defaults, making things easier for us, as we code. And then we have the level 3 or higher level constructs. And these are really opinionated abstractions because they can wrap complete setups. They can wrap complete architectures, small ones or larger ones. And these are constructs that we can write ourselves. And we can, for example, share them within our organizations if we want to wrap organizational best practices or patterns within those constructs. Or we could find them on GitHub or publish them ourselves in GitHub, or make them available through repositories like Maven, for example, in the case of Java. If we take a closer look, at what this means, these different levels mean, the level 1, as I mentioned, is just a one-to-one representation with a CloudFormation template. So it will start with a CFN in its name, and then it will continue with the name of the actual resource, in this case, a bucket, an S3 bucket. And if we synthesize that, we'll see we get really just a one-to-one translation into an S3 bucket in the CloudFormation template that we get, just one resource, which is the bucket. Excuse me. If we look at level 2 constructs, and for example, we want to start with a VPC, a lot of architectures in AWS start with a VPC, so it's a pretty common setup. If we instantiate it briefly like that without specifying any properties, just a scope and an ID, and we synthesize this to CloudFormation, we'll end up with an architecture or infrastructure that looks more or less like this. As the documentation that we will also have available in line in our IDEs tells us, it has automatically assumed a CIDR range, and it has split that IP range into 4 subnets, making 2 of them public and making 2 of them private, specifying an internet gateway to provide inbound and outbound internet connectivity for the public subnets. It has created route tables, route table associations, and so on. And we didn't necessarily need to specify all that. It made these assumptions for us, and it made it super easy to create what would be a super or much larger CloudFormation template than, it will have much more than one line of code, which is what we've written here. If we take level 3 constructs, we're going to see these are really reusable compositions, reusable patterns. Here I'm specifying a Fargate service, and I'm giving it a cluster that I've specified up here, and I'm giving it a task image or a container image that I've specified here from a registry. And it's really a few lines of code only. And if we convert this into a CloudFormation template, this ends up being 129 lines of YAML. And we end up with an architecture that looks more or less like this. We have a container. It's coming into this task definition for ECS, our managed container service. It's specifying a Fargate service, and it's specifying all the permissions and policies, the login groups that need to be available, and all the networking components that need to be also present, like subnets, internet gateways, routing tables. We didn't need to specify that. Everything is wrapped in here. And we can, of course, override those properties, but if we don't, this very high level construct, level 3, wraps this architecture and sets up the rest for us. AWS has made available a library of L3 constructs, which is called the solutions construct. And this will wrap compositions. Its constructs will wrap compositions of common patterns, like an API gateway fronting a Lambda function, or API gateway writing directly to DynamoDB. And you can reuse those. So if you have 10 or 20 native constructs or services on AWS that you will need in your architecture, you can start picking and choosing some of these, and you will end up with less components because they will wrap smaller, or it will wrap services within them. So you take one that already has 3, or one that already includes 2 of them, and you end up with less moving pieces in your code and less code that you actually need to develop. Before going into a quick demo, just to let you know, there are some, of course, prerequisites that that we'll need before start working with CDK. We'll need to install Node.js, because we are going to need to install also the CDK toolkit and CLI, and that happens via the Node package manager with this command. So there are instructions online how to do this, detailed instructions how to do this. And once we've done our installation, we can quickly verify that everything is fine by listing the version of CDK that we have. And now I would like to show a bit of a quick demo, really simple architecture, where we have an API implemented in AWS Lambda that is fronted by API gateway. So we provide a REST API in front of it. It will simply do a hello world, because, you know, all great code always starts with a hello world. So let's do that. I'm going to switch to the other screen now. And now it should be my other screen that's visible. Yeah, so if we want to start from the command line in CDK, of course, this assumes that you have the JDK already installed, because the examples here are in Java, and that you have the AWS CLI already configured, so your credentials are there and it's working, and you'll have a region already selected and all that. So we can, as I mentioned, list our version in order to verify our installation. And we can also, in a given directory, initialize a CDK application. So if I do CDK init without specifying anything else, it will list for me the available templates that I have. So I can initialize with a template for an application in different languages, or I can initialize already with some sample code for a specific language. And if I want to create libraries, polyglot libraries starting from TypeScript, to make them later available in multiple languages, I can also do that with CDK init lib. I've already run this command for Java, so I'm not going to do that again. But once I did that, that generated for me this structure. So it created a project for me. There was it was a Java project, so there is using Maven as a dependency manager, and it already included the CDK core in the POM file, and it provided some sample code. So it already created the skeleton, so to say. So we have an application, which is the starting point of our code in a CDK application. And within that application, it included already a stack, right? And specifying a scope and an ID, and also some optional properties, as I mentioned. It provides us some comments as well of what we can do here. And it defines the stack itself, which is where we're going to put our code. We're going to specify the resources that we want in the cloud. And here it's, for example, telling us you could create a queue, you could specify an SQS queue, just uncomment this, and then you'll have it there. For the sake of time, I've already created some code here. So I've cleaned up things a little bit, and we still have our application, and we're still including a stack here. And then we're synthesizing everything into CloudFormation. If I look at the stack, I've specified the architecture that I wanted here. So we wanted to create a Lambda backend with an API gateway. And this is just what I did here. I specify a Lambda function, and you can use the constructor, but in the Java language, the constructs that are available in CDK, in the CDK modules that you will import, implement the builder pattern. So you will also have a builder static class available to you with creational methods and methods for setting the properties that you will need. There are some properties that will be mandatory. In the case of a Lambda function, we need to specify, of course, a runtime. What is the programming language that we're using, and what is the runtime to execute that code? I've chosen, in this case, Node.js. We need to specify the code that will run into that Lambda function. And I've specified that from an asset. I've said, hey, take the path Lambda and find the code there. And I have the directory Lambda here, where I've specified a hello function and exported that. And this is doing nothing else in Node.js than print hello build stuff. And I've specified the handler. So what's the name of the function that I'm exporting? And then I'm simply building it. Then we have our Lambda function, and the next thing is simply to front it with API gateway. So I create a REST API, and I say it should be of Lambda proxy type. Again, I use the builder pattern that is available and create that REST API. And the only thing I need to pass as a mandatory property is really what is the Lambda function that I want to front with this REST API. And actually, that's it. Of course, before being able to use this code here, I needed to import the correct dependencies in our POM file. So the core was already included. That's why we could start with our application. But I also needed to include Lambda, and I also needed to include API gateway, because this is what we're using here. If I go back to the command line and go to the directory where I already have this code, I can do CDK diff to ask, hey, what is the difference between what I have just developed and what is in the cloud in my AWS account? And it will tell me exactly that. It will tell me, hey, if you were to deploy that, all these resources are going to be provisioned into your account. I'm creating, through your code, you've created these resources, and I've added some permissions that are necessary to connect those resources. And this will be the output that I will give you. You know, CloudFormation also has output. CDK also exposes some output. And I won't do this, but because for the sake of time, but you can simply then just do CDK deploy to really execute this into the CloudFormation engine and have that deployed in our AWS account. And it's going to ask me to confirm, and it's going to list again the changes that will be applied. It's telling me there's going to be these permission changes, and you're going to be creating these resources just in case you want to review that. And we can click yes, or we can enter yes, and then the process will start. We will not wait for that because it takes a little bit of time, of course. So I'm gonna switch my screen again to go back to the presentation and talk a little bit more about CDK and coding in Java. One thing that we didn't see directly in the demo that I just did was that CDK also makes it much easier for us to grant permissions. If you've worked with AWS before, you know that you just need to specify IAM policies, roles, and attach those roles to principals, to users, to AWS services that want to use other services, and so on. And this, if you want to specify that in CloudFormation, can take a while and becomes a little bit long. With CDK, the constructs that we're using expose methods for us to grant those permissions. And this allows us to really make these permissions and create those permissions with one line of code. If we look at an S3 bucket and we want to grant read permissions to a bucket, for example, to a Lambda function, we simply invoke the grant read method and pass the Lambda function as the principal that will get that permission. The grant methods expect any object that implements the iGrantable interface. In Java, you'll have that interface available. And Lambda functions implemented, and that's why I can pass the Lambda function here. I could do the same, for example, with a DynamoDB table. If I want to grant read and write for the data that is stored in DynamoDB, then I can also pass a Lambda function, or I could do this for granting permissions for writing into an ECR repository, or granting permissions to use an KMS key to decrypt or encrypt data. It's really just one line of code, and we don't have to take all this effort of specifying that in CloudFormation. One thing that I want to mention, and just very briefly, is that the CDK philosophy tries to unify the management of application source code and application configuration together with infrastructure as code under the same roof. So in a single code repository. And this is what we can implement with CDK pipelines. So it really follows a GitOps model. So in our CDK application, where we've defined our stack, we can also define a CDK pipeline. The CDK pipeline is also a stack, and that's why it can live right underneath a CDK application. And with within the CDK pipeline, we can specify stages. It's also a construct, and we can create one stage for our infrastructure for production and include that stack that we've seen before. And we could do the same for pre-production. And we can have the stages that we want. One that obviously listens for code changes in our code repository, one that builds that our code with language-specific commands like mvn package or mvn compile. And to use that, we need to import a module as well, which is called CDK pipelines. And you need to deploy this pipeline into the cloud once. Once it's in the cloud, all you have to do is make changes in your code, whether you are adding a new stage in the pipeline or whether you're changing your infrastructure's code within this inner stack. You just push there and the pipeline will self-update in the cloud. If you add one stage, the deployment of that pipeline will include that new stage. If you're adding a new construct here, it will deploy that new construct as well. It will update infrastructure. So this is pretty cool. And you can dive deeper into this by listening to this AWS Online Tech Talk. And before we close, just want to give you a view of the open ecosystem that is rising again, like around CDK. CDK is open source. It's available on GitHub. The roadmap is open there, and you can go there and vote for your preferred feature. So you can help us prioritize stuff. You can also submit your own code in the form of pull requests to help us extend and implement CDK. The CDK programming model, this idea of having a tree of constructs and synthesizing it to CloudFormation to configuration artifacts, is actually being applied to other projects. We have projects like the CDK for Terraform that have also emerged, where again, you can take your favorite programming language and synthesize it, in this case, to a Terraform configuration file. You just create your construct tree in code, and then you end up with a Terraform configuration file, and you can deploy this to any cloud that you want. And I encourage you also to dive deep into that if you're interested with this webinar available by HashiCorp. There is CDK for Kubernetes as well. Again, define your Kubernetes deployments in code, and you end up with a Kubernetes manifest that you can deploy also to any self-managed Kubernetes cluster or a Kubernetes cluster in any cloud, whether it's AWS or not. And also available in multiple programming languages, and also comes with a CLI, of course, kind of a sister of the CDK CLI, but for CDKs. You can dive deeper into this as well. This is a talk of the last reInvent. Just to list some resources here, if you want to learn, you can get a guided experience through the CDK workshop. We also have an advanced workshop focusing more on CDK pipelines, which I mentioned today. There's a super nice collection of CDK patterns that are serverless patterns that you can reuse in your applications. And I've mentioned already solutions constructs made available by AWS. And there is this awesome CDK list where you can find pretty much everything that exists around CDK, projects, code, documentation. And I'd encourage you to attend the next reInvent virtually to learn what's coming or what's next for CDK. There will be, of course, some updates there. Virtual attendance is free, so go for it. And with that, I'll close, asking you to please kindly fill this survey and provide feedback on this session for me. I really value your feedback. I'd like to know how we at AWS can make things better and which topics we can present to you next. So this will mean a lot to us. I will paste this in the chat. Also, if our kind moderator could paste this and on Pine, that will mean a lot to me. And with that, we can move to some questions.
Diana, thank you so much. I just pasted that survey in the chat, everybody. I hope, let me see, I got it right.
Great. That's great. Thank you.
While I wait for any questions, I had one myself about the level 3 constructs. So I'm sure AWS publishes quite a few of those for us. We can make our own then as well, right? Like if I have a if I have a series of stuff, cloud infrastructure I end up creating, I can create my own level 3 constructs and then reuse them later on, right?
Yeah, that's correct. That's correct. You simply extend the construct class. I mean, if we talk about Java, you would extend that class. Yeah. It will force you to implement the constructors, the one where you can pass null properties and the one where you specify the properties as well. And this is where you will include your little architecture, your pattern that you want to reuse and so on.
Awesome. That's great. I love that. And I love, as somebody who has seen some stuff with IAM policies, I really like the very nice ways you can give bucket policies and assign those just built in as methods. That was very nice. Just wait a few more seconds, see if any questions that came across. I'm not seeing any right this second. So Diana, thank you so much for your presentation.
You're welcome. Thank you guys for having me.
Thank you so much. And reminder to attendees that tonight is the attendee party, both in person and virtual, at 9:45, I believe, local time, Central Lithuania time. And thanks again, Diana.
Thank you, guys. Thanks, everyone. See you.